Hi all, I'm Marcin, I'm senior Flutter developer at Montreal, and now it's the time for my architectural talk. However, before we jump into those pretty abstract topics that I wanted to present you, I would like to remind ourselves, why do we bother really with proper architecture? What are we preparing for? What are we fighting for by thinking ahead? And I would like to do so by presenting you in what's coming in the nearest future. First and foremost, my switcher doesn't work. Okay. The technology that keeps things interesting in the past few years, namely artificial intelligence. I know it's a very polarizing tech. There are very bogus applications that are coming to the market at the moment, but there are also valid ones, and I would like to focus on those ones. So we are at the AI gold rush stage of AI adoption. It happened before, it will happen in the future. What those previous ones teach us is that the initial hype of a technology and the potential applications in every field imaginable, those were false, but that doesn't mean that technology isn't viable in some rather more narrowed down areas. And that's exactly how I think about AI in different areas of our world. Also, whatever you think about AI, it already has changed the way that users perceive your applications. The users expect your applications to behave. So at best, you can just take a look and see what's coming, maybe prepare brace for that. Yeah. I will be mentioning a future a lot in this presentation, but I wanted you to know that it's not a hypothetical one, nor is it far-fetched. I will be starting with presenting you some prototypes that have code bases open, so you can examine those yourself, up to solutions that are actually implementable today as we speak. First prototype, that's a runtime for desktop. It's a web agent that can perform actions or do research on behalf of the user. So the idea is that the user can log in as normal to, let's say, their Gmail account, and then we can task the agent to send an email, for example. And the idea is that the developer behind the application is not really aware if the action being taken is taken by a user, actual user, or an agent. There's no way to tell, at least not an easy one. This specific one navigates keyboard and mouse friendly interfaces with relative ease, struggles a bit with gestures, but luckily there's not much on the web. Which isn't true for mobile. We have App Agent for mobile that's a mobile alternative to runtime, let's say, but a bit more prototype. It has been run from the terminal at some point, potentially on device. But as you can see, it has this additional human demonstration step, which is optional. But the idea is that mobile interfaces are much more gesture-based, much more adjusted for human hands, and that's exactly what agents struggle with. As impressive as those agents are, if you test them out, they actually can do some job properly. I always have this question on the back of my head when I see something like that. Just think about how inefficient the whole process is, right? There are product teams making UI and UX nice for humans, so few humans are happy and focused and it's intuitive, and that's exactly what agent struggles with, right? Every gesture, every data that is spread out into in white spaces or in slices between different pages, so the user can consume that without much cognitive power. That's exactly what agents struggle with, because they don't have the full data. They don't know what actions to take to navigate to get the data. Computers work best with structured data, so that's what we should give it to them. And we have the concept figured out. I think we have APIs, we have, for more modern audience, we have MCPs. So we need something similar for mobile. The game plan would be that we need the user and an agent use the same interface. So as the first prototype, the user, for example, can set up the application, but then the agent can jump in for the user in any step of the way. We have to predefine what our application can do, and then also, on the other hand, what data does it have access to, and what data does it understand. Now, the demos you saw before, those were prototypes, and now is the part that we are switching to solutions that are ready for implementation today. namely custom Siri commands. Siri has been with us for a while now, but it has been taught new tricks along the way. And the trick that I like the most at the moment is custom commands. You can teach Siri as a developer what your application can do. And it's not a simple string to intent mapping. Rather, you can also define variables, and those variables are domain specific to the application. So Siri has this disambiguation process that will make sure that the user, whenever defining a prompt, actually will do something that is viable in your application. It's not just a string from the text, but rather actually valid application or data. So your application can then run essentially as a deep link, very simplified way. You can also make your application chainable with shortcuts. It's like Siri, but you can define the chain of actions yourself spanning throughout different applications. There's also in the disambiguation process. In here, in this demo, it's manual, but those shortcuts can get much more elaborate. For example, let's say picking the correct workout based on the day of the week. And then also the application can be launched essentially as a deep link. Now, if you think about it, that's exactly what we defined in the game plan. We have the actions and we have the data. So that's it's ticked off. And now with current LLMs, even the local ones in mind, imagine how close we are to having Siri or Apple Intelligence, or whatever the name the solution have on your device. Imagine how close we are to constructing shortcut scenarios based on Siri command, for example, or any natural language prompt. The data is here, the technology is here, just waiting for Apple, really. Introducing, I'm happy to introduce intelligence. That's the plugin that you saw in action before. That the plugin opens the world of app intents, which is the framework underlying under the Siri and shortcuts works. So the setup is pretty simple. On the Dart level, you deliver the data available in your application via the populate method, and then you receive the selections from a user or an agent, doesn't matter, via the selection stream. Depending on the native level setup, your application can present its content through Spotlight search, Siri commands, and shortcuts. So even if you're not really into this whole AI and agent stuff, what you get here with intelligence is essentially free real estate throughout the operating system. So your application is easier to launch, easier to find, more tied up to users' operating system, feels more natural to open. Now on the receiving end, the selections are delivered simply by ID. I'm saying simply because it's simple for me. I wrote the plugin, I can just push you the ID that you presented me with. However, the real work starts on your side. As this gives you the whole new set of entry points to your application that can be actually run pretty unpredictably. You have to resolve the ID into the full data structure that you were given. Your application might be closed when the selection happened and only booting on, or maybe it was already running. And if it was running, maybe it was doing something that shouldn't be interrupted. So potentially there's a queue for you to handle because of that. And many more considerations that are specific to your application that I don't even know of. I would like to help you with some of those problems by presenting you with a modular and flexible yet lightweight architectural approach. The idea is that everything is a tree. We start our Flutter applications with trifecta of trees anyway, so why not add another one for navigation specifically? My favorite perk of trees is that you can split them into subtrees, and that makes development of your application feel like dealing with a lot of mini applications just under one umbrella of solutions, which lowers the complexity whenever you are working on a new feature, and even on the old one, you don't have to care about the whole idea, about the whole application, but rather you can focus on dependencies that you actually care about in this scenario. In this example, we have two dependencies, docs repository and off service. Those, as you can see, can be nested. And those are defining our mini applications. My favorite second favorite perk of trees is their ability to grow both vertically and horizontally. So on the previous slide, off-service did look like a global dependency, but in my opinion, there should be no such thing ever in your application. Global dependencies are really your predictions about the future, and I would like to avoid gambling in my day-to-day job, if you don't mind, because each global dependency adds each global dependency adds complexity to whatever you are doing in the future, even if the new feature doesn't need that dependency available, as in this simplified example, there's onboarding that doesn't need any dependency actually to run. Another reason why you shouldn't add global dependencies as then often slow down. So we are waiting as developers. It's convenient for us to wait for them to set up, to do some network call or whatever else they might need to do before actually running the run up command in our application. And I believe Flutter engine, don't want to take this as a minus, but Flutter's engine takes enough time to boot up already. So you should render your first frame as fast as you can. The users don't want to stay any longer on the splash screen. Now, let's say a user or an agent wants to or are tasked to edit a doc. In this example, we spawn only the dependencies that we need. So in this example, we have off service and then docs repository. Is it a lot? In this example, it's actually everything that we have in our application, right? Maybe it is a lot, but it's exactly what we need at this to handle this request from the user. If we would be starting onboarding, there's nothing to load. So that presents that the beauty of this approach is that the complexity scales automatically depending on the task at hand. Two main concepts to achieve the modularity and flexibility we desire are stateless navigation and context-driven dependencies. A bit of theory regarding stateless navigation. It sources vastly from the web, or in other words, document navigation. And the first point is that your route should be independent. You shouldn't care about the current navigation stack, as you can predict what the user or an agent will do in your application with this many entry points and which order. So you're just given here and there, that's what you need to do, and that's exactly what you render. Next up, every route should be named, and yes, that also includes models, and that ensures that you actually have a flexible way of jumping around the application. And lastly, you shouldn't await for other routes response that directly contradicts stateless navigation, but we have this very popular awaiting for navigator.push, and that's problematic because in this approach, at least, because it binds two routes together forever. They can't function without each other, or at least are meaningless, as they expect always to be in certain order in the stack. Now, bring your own tools to this approach, but to show you some code, I picked autoroute. That's a declarative tree-like structure that we look for. Any autoroute users in the audience? Okay, a few hands. Pick whatever you like, just something that can create those subtrees for you in the navigation level. As for context-driven dependencies, as mentioned, there should be no global dependency ever. I think I covered this enough. You should also use your dependencies in a stateless manner. So whenever you are reading data from a dependency, it should be synchronous, as well as the actions. Those are mostly requests to the dependency that will then let you know that something has changed, rather you waiting for the future to await on the widget level, as this binds a bit too much the logic with the UI level, essentially. Dependencies, lastly, should be created on demand. So no pre-warm-ups, no waiting for something to load before you render stuff. You first render your even loading indicator in Flutter, and then you deal with the data that you should load. So user is informed and is happy with whatever visuals you have in your application, rather than your splash screen. I picked Flutter block to demonstrate this one. Any users in the audience for block? Yeah, that I'd like to see. However, again, just an example, I don't want to dictate the state management solution for your application. Just pick something that can scope out your dependencies and do so preferably with build context. If there is one thing I'd like you to take from this presentation home or to your work is this. Change is the only constant. We are talking about agents today, but the truth is that this approach predates agents and probably will also outlive it. The idea is that whatever paradigm comes next, it will be another module in the tree or another entry point into the tree that is already existing. Stay focused on the current development. Be ready to branch out at any time. That's the motto of this approach. Thank you.